removal in crops using robotic system, we named our bot as WeBot. My teammates are Prajakta, Nalapriya and Raghavashni. Here, agriculture is the sector we have chosen for our project, which is a laborious sector, and nowadays people are not opting that sector, which is a very important sector. We try to automate the agriculture sector. Here, weed removal is the part of agriculture which we are trying to automate. Nowadays, weeding techniques are two. There are two weeding techniques. They are weedicide spraying and manual plugging. Where weedicide spraying causes adverse effects in crops and manual plugging is laborious and people are not opting to do those jobs. The mechanisms we are used here are image processing and deep learning to capture the image and detect the weeds, and we are integrated IoT to automate the process. The software and hardware requirements are Arduino IDE Genie, which is in C++ IDE, Chases Kit L298 bridge, which is a motor driver, Raspberry Pi processor, Raspberry Pi cam, and Arduino board. Power source will be from power banks and a customized ARM. We have divided our project into two processing sectors, slave processing sector and master processing sector. Slave devices are Arduino and Hatch Bridge, and master devices are Raspberry Pi Cam and Raspberry Pi controller. We have further divided our project into hardware sector and software sector. First, I will be explaining the hardware, and then we will be moving to the software.
Now I am going to explain the hardware parts. This is the Chases kit we used for the project. The power source will be from power bank. Here this is Raspberry Pi controller for image processing techniques, Raspberry Pi cam, and Arduino for controlling the Hatch bridge, which is a motor driver to control the DC motors of the wheel. This is our customized arm. We have 3D printed this arm to plug the weeds. This arm will be controlled by the servos. I will be connecting the Raspberry Pi to my laptop through remote access. Here I am going to connect my Raspberry Pi to my laptop through IP address of my phone. Here it displays the Raspberry OS through which I am coded my bot. Here I have used two files to code my bot. One is sample file and another one is machine learning file. The sample file is used to sample.cpp is the program which is used to capture the images of the weeds. Here I have used OpenCV library, Raspberry Cam library, which is a library for Raspberry Pi Cam, and IOStream, Chrono, CTime, and Wiring Pi. Wiring Pi is for pins of Raspberry Pi, pin configurations of Raspberry Pi. This is the code for setting up our camera with appropriate width, size, and pixels. Here I have passed the arguments to open up my camera. If my camera is opened up and getted the camera ID, it will be connected successfully, or if the camera failed to connect, the failed to connect message will be popped up. The camera ID will be get automatically through the Raspberry Pi Cam library. Camera.grab is to grab the pixels. The retrieve frame is to retrieve the frame which is captured, and color is converted BGR image to RGB image for high resolutions. This function will, if we tap any keys in our laptop, it will take the photos in various angles. We can fit the camera and we can take the photos through this program. the pictures captured in that program will be trained for machine learning. This is the main program to automate our bot. This is also written in C++. And in this also we have used the libraries as of in previous program. Here these are the matrix variable. Matrix variable is used as the variable for images. The vector variable is to process those images. Vector is the function like stack, which will store the image pixels as of in stack. Point 2f is the variable which is used to point the coordinates in the images. Here some camera setup is being given. Capture is the function to capture the video. Perspective function will show our image in perspective view, which is the bird view. Threshold is a function where the image will be converted to black and white image for some row ending functions. Histogram is the function to check out the frame center and the frame edges and to fix the coordinates. Row finder is to navigate the bot in the correct direction according to the weed. Row center is to center the bot according to the weed. Weed reduction. Here I have given a hair cascade file which will be present here in the machine learning folder. This cascade file is helpful for detecting the weeds. We are having a UI for creating those customized hair cascade files. Here if the using the hair cascade file, the moving rover will detect the weed. If the weed is detected, the frame is set up and a rectangular box. This is the code to draw a rectangular box to it, and this is the code this is the line of code which is used to find the distance of the weed. Here we are entering into the main function. First we call upon all the sub functions we have created, and here is the digital signals which will be passed to Arduino. If the signal is if 21, 22, 23, 24 are the GPIO pins of Raspberry Pi, if these pins are set to 0, 0 and 1, the decimal signal is 8, which is sent to Arduino, and the Arduino will take care of the rover and servo functions. Let's move on to the Arduino code. This is the Arduino code which controls the motor and the servos. So servo.h is the header file used to is the package for server. This is the forward function for rover, backward function, stop function, that is for stopping the rover, servo function, U-turn when the Raspberry Pi cam instructs it to turn around the row end, it will turn, which is used for turn in the row end. void crop is the crop is the function used when the Raspberry Pi seems the crop. If the data is 0 from the Raspberry Pi, it will move forward. If the data is 7, it will be moving, which the data will be coming from a GPIO pins. That if the data is 7, it will be turning U-turn. That is, if the data is 7, it will know that it is a row end, and 8 is the decimal number. It comes from a Raspberry Pi, which indicates it detected the weed, and it is the program to plug the weed. That's all about the software part. Then I will be showing you the demonstration of our project.